Hey folks, so for our next guest, we have somebody from Modzy. So hello guests, what's your name, what do you do, and what's the organisation, what does the organisation do? So many questions to strike us off.
My name is Nathan Mellis. I am the the director of engineering for Modzy. So I lead all the engineering efforts for the company. Modzy is an AI startup. We build an MLOps product designed to help you go that last mile to get your models into production.
Interesting. Okay, so tell us more about that. So for somebody who's like an average developer that's been playing around with some kind of ML, I mean, what does that journey look like?
There's been a lot of activity in the AI space around training models. So we've got these great libraries like TensorFlow and PyTorch and the like. And data scientists will build these awesome models that do cool stuff. But the things that make you a great data scientist don't necessarily translate when it comes to putting software into production. That's more, DevOps or, scalability, security, resilience, failover, all those sorts of things are not sort of in a data scientist wheelhouse. And so our product makes it really easy for them to take the output that they're used to working with, which is the model, and then we'll package it up and deploy it to a system that does all those things for you, including all of the, sort of unsexy, but, important things like, auditability and governance and, all those sorts of things that large enterprises require, but that are just, it's not the fun part, but it's extremely necessary.
Yeah, I think it's sexy depending on what side of the fence you're sitting on, maybe. I think for somebody who deals with all that stuff all day long, it's probably something mighty powerful and mighty sexy. Anyway, enough of the sexy. Maybe to more sexy, actually, thinking about this. Where does NATS fit into all of this?
So NATS is kind of the backbone of the whole system. So in order to achieve a level of scalability and sort of performance, all of the model inferencing is asynchronous. So you'll submit some data to be processed, and then that goes into a queue, and then Modzy will determine which model needs to run it. It will spin up that model. It will drain the queue and then shut the model down. And that happens for hundreds, thousands of models. And so NAT sort of is that queue, that backbone for queuing up that information that then can get worked on asynchronously. And the benefit to this is that you don't have to have your models running all the time. So if you're in the cloud and you have support for auto scaling, then if you don't have any inputs for a particular model, the model doesn't have to run. And this can be a huge cost savings, especially since a lot of these models require really expensive GPUs in order to run. And so one of the things that our product, I think, does really well is give you all the flexibility of having access to all of your models at any time, but only runs them when necessary. And so you get that nice balance of accessibility and ease of use. Without you having to think like, okay, I got to spin up the model before I, do this. And then I have to remember to shut it down. And then, oh, shoot, I forgot to shut it down. And now my bill is huge and we're going to go bankrupt. And,
Yeah, not like we've never been there before, I'm sure. Yeah, oops, I've left some things on I shouldn't have. Yeah, the AWS bill is terrifying. Never mind any of the newer startups.
Yeah, I love the meme of a guy talking to what looks like a homeless person on the bench, and it's like, what was it? Was it drugs, gambling? And it's like, no, I left an EC2 instance on.
Just off topic. This happened to me. I think the other month. I literally had a $700 AWS bill on my private account. What did I do? Oh no, I forgot the experiment was running. So yeah, we've been there. So there we go. Modzy might have saved me. How is Modzy deployed then? I mean, is this like an on-premises? Is it a SaaS? I mean, how does that look?
Yeah, so Modzy runs basically anywhere. We run on top of Kubernetes. So anywhere you can run Kubernetes, you can run Modzy. We're very at home in the cloud. We support all the cloud features, auto scaling, security, load balancing, all that good stuff. But we're just as comfortable in bare metal, on-prem, virtual machine, kinds of situations. And in fact, we have customers all, in both places.
Interesting, got you. And I've got to ask some kind of probably super boring questions now. When did your exploration of NATS begin with Modzy? I mean, was it kind of early days, or was it kind of later on? And how did you find out about NATS in terms of its capabilities and its fit for the Modzy product?
Yeah. So actually, it was later on in our process that I got introduced to NATS. One of my colleagues had been exploring it in a previous position for a service mesh, and was pretty excited about it. We were using a different queuing software at the time, but it took up a lot of resources. It was hard to configure, and you could only use it pretty much one way. So it was over a break or something. I just started watching some of your YouTube videos and just reading through your documentation, and started to get really excited because NATS has some features in it that weren't in the other software that solves some problems that I was wanting to solve. And so then, we, started talking with you guys, and and then, over the course of several months did a full transition. And then of course, it enabled us to build some new features that we had been wanting to build out, particularly being able to run models at the edge. NATS, some of the features in NATS, and I'm happy to go into those if you want, enable us to do that in a rather elegant way.
And I would love for you to go into that. I was just about to say, how does NATS change the thinking around Modzy? But also, I'd love to understand the kind of points of adoption, obviously NATS being really a superset of features.
Yeah. So the first feature that we sort of took advantage of was just the fact that it took a lot less resources, which is great. The second was, so if I think about like a theme for our NATS journey, I would have to say topologies, which is probably not the answer that you were expecting. But one of the things that we really like about NATS is that it enables the use of rather complex topologies for your queues. You've got your standard sort of cluster, high availability, data resilience with Jetstream, and that's great. But then the ability to do superclusters enables you to do multi-cloud or hybrid, where you can take the information and spread it across different geographical locations, which is very difficult to do traditionally without some sort of like crazy setup. But at the edge, we're actually using leaf nodes, which are great because you can have a portion of your topic or Jetstream structure that can be interacted with from a leaf node that is otherwise independent. And so that enables us to have like self-updating edge devices, so that when you make a configuration change from the central hub, those changes can get automatically pushed down to 10,000 devices, which can then all reconfigure themselves and do it instantaneously. You don't have to be polling. You don't have to, do some sort of check-in or reconciliation or whatever. And of course, it's all over a single connection, which is secure. And so you don't have to have multiple connections open. You don't have to have multiple ports open on your firewall. We're actually doing it all over the WebSocket connection. So the edge devices only ever have to talk on port 443. So you don't have to worry about network firewalls or things like that.
Interesting. Just on that topic right there, how do you balance connections across infra? Do you let just kind of NATS take care of that with gossip, or do you go down the kind of L4 load balancing and kind of routing?
No, we let NATS / Kubernetes take care of it. So we run NATS in Kubernetes, and so we let Kubernetes do its thing.
Gotcha. That makes sense. So delving in a little bit deeper then, so let's say you made the migration, NATS came along and you embraced it, and and thank you as well for the great, it's really kind of story on the topology front. And I think that whole, I don't really like calling it multi-cloud, but let's call it multi topology. It's super powerful. But when new problems come along now, what's your typical thinking? I mean, do you start to view the problems through the lens of NATS, or is it more you kind of keep in the back of your mind the super set of features that NATS brings to the table?
More so the latter. We have APIs, we have databases, we have NATS, we have like our product is a conglomeration of a bunch of different things, and NATS is a very powerful tool in that tool chest. But when we're looking at new features, we'll look at sort of the sum of the capabilities that we have or would like to have, and then figure out what the best way of doing that is. And so, NATS often comes up in the conversation. For example, we are discussing using request reply topics much more regularly rather than writing an HTTP or gRPC API, which for now it's 6 of one, half dozen of the other. But when you start thinking about multi-cloud or hybrid cloud or something like that, then that means that you have to have, if you're using HTTP or gRPC, then you have to have those services deployed in both of those locations. You have to have some kind of a service mesh so they know how to route between them. You have to synchronize data across your various data stores, and it's very, very complex. But with NATS request reply, you just send out a request, and if the cluster that you're in knows how to answer it, it will answer it. If it doesn't, that'll get percolated out to your supercluster, and then someone else can answer it. And so it makes interacting with these sort of complex topologies, it makes interacting with them and reasoning about them much more simple and straightforward, and also greatly simplifies the sort of networking and infrastructure that you have to set up in order to be able to support those complex topologies.
Fantastic. In terms of Modzy's software modules, dare I say, what languages are those kind of written and constructed in? Are you kind of like typically a single language kind of shop, or
no.
Are you kind of polyglot?
We are very polyglot. So we started doing Java mostly because our clientele at the time was mainly government, and there were restrictions on what you could write software in. But we now primarily use Go for all of our new stuff. Of course, we use a lot of Python because Python is the ubiquitous language for AI. And then we've also started introducing some Rust recently, in addition to the typical JavaScript and TypeScript for the front end.
Yeah. And I'm going to ask probably a very brave question at this point. Are you happy with the kind of surface area of support for NATS for those languages?
Yes. I mean, it's nice that there are client libraries that are made available on GitHub for pretty much every language, and I have enjoyed that they have been written in a way that is appropriate for the paradigms of that language. So in Go, you can use Go routines, and it supports that kind of thing. And in Rust, they follow the traditional Rust sort of like way of writing things. Sometimes when you have libraries that are written in multiple languages, they're all written the same way, even though the expression and sort of like natural best practices for that language are different. And so I always appreciate it when a library is written appropriately for the language that it's in.
Yeah. No, thank you for that. And that's a really nice point as well. It's difficult, I think, to kind of meet people where they are.
Idiomatic. That was the word I was looking for.
I was trying to pull it out. It was like a Harry Potter scene with a wand, and I just stabbing myself in the head, but it wasn't coming out. Thank you for that. Idiomatic. Yeah, I was going around like the whole Pythonista route and all that, but yeah, idiomatic is absolutely the word. Thank you. Saved me from embarrassment. Yeah, I do a lot of that as well. Thank you for all this, by the way. I mean, all of this information, the kind of insight, and I guess the confidence that you have in NATS, it means a tremendous amount to hear this. So thank you very much. And whilst these videos are short and sweet, is there anything that you'd like to say to the audience? Any kind of last minute kind of thoughts or any gripes? Feel free to kind of splurge some inner goodness, whether it's good or bad.
I'll just say that AI is an exciting place. It's ever changing, and it's been a joy to be a part of it. And it's as a software architect myself, it's fun to have new and interesting tools in your toolbox that sort of grow your horizons and challenge you to think about problems in new ways rather than always thinking about things in terms of lamp stack or something like that. It's like let's push the boundaries and the envelope. And certainly sort of the microservice revolution has done that, and Kubernetes based applications cause you to think about things differently. Rather than just throwing everything in a database, thinking about, would a disk persistent queue be better and enable you to, do things differently, and just think about, solved problems and, solve them maybe better. And so it's a fun time to be alive.
Absolutely. Couldn't have said that better myself. Fun time indeed. So thank you very much. And before we leave, where can people find you if they want to reach out, and where can they find Modzy?
So you can find Modzy at modzy.com. Shocker, I know. I'm on LinkedIn and that's pretty much it these days. N8 Mellis on LinkedIn. Yeah.
Thank you very much, sir. And all the best with Modzy.
Thanks.